All right, what should you put on your conservation of momentum note card? A few things. I would definitely put the equation for momentum. Remember, P is momentum, and it's mass times velocity. If you struggle with units, you might want to make a note that momentum can be either kilograms times meters per second or newtons times second. Mass is, of course, measured in kilogram, and velocity is measured, of course, meters per second. There are basically three types of situations happening here. We have explosion problems, which can look like one of two things. You can have two objects that are originally at rest that afterward are they're gonna push off of each other and they're gonna fly apart. Or you can have two objects that are originally flying toward each other that once they smash into each other come to a rest. What's important about explosion problems is that the momentum is zero either at the beginning or the end. So the equation would look like this. For this guy on the top, the equation is 0 because everything starts out at rest here, okay? And we're gonna have m1 v1 afterward plus m2 v2 afterward. For this guy down here, we're gonna have the opposite. So it's gonna be m1 v1 before plus m2 v2 before equals 0 because afterward it's 0. So that would be nice to have in your card. Another situation we dealt with are where you have two separate objects, and these are called inelastic. So you start out with two separate objects. One could be moving, one could be at rest, they could both be moving, doesn't matter. What matters is that afterward they are stuck together and moving together. And the equation we're going to use there kind of almost looks like the situation. We have two separate things, m1 v1 plus m2 v2, so two separate objects, equals, and afterward they're going to be one kind of giant mass together. So we're going to write them that way, m1, m2, v afterward. The last scenario is where we have two objects that are separate to start out with, and after they hit, they're going to be flying off kind of separately afterward too. So a really good example of this would be like bumper cars. And the equation sort of looks exactly like that situation. You have two separate momentums happening, so m1 v1, m2 v2 equals, and afterward they're separate again. m1 v1 afterward plus m2 v2 afterward. Very important in all of these. Remember that momentum is a vector, so direction matters. So you need to make sure you have something going, if something's going to the right and you decide that that's positive, you need to stay consistent throughout the problem. If something's going to the left and you decide that that way is positive, you need to stay consistent throughout the problem, especially on these elastic ones. So you may want to make a big note, watch direction. That is a key.